Hi and welcome. I'm Matthias Bavet from the WSA Institute for Snow and Avalanche Research in Davos, Switzerland. And today I want to talk to you about our Data Access Made Easy effort, which is our way to provide flexible, on-the-fly data standardization and processing for research automatic weather stations. So first, maybe I need to clarify why this focus on research automatic weather stations. If you look at large monitoring networks, for example the WMO network or the EMIS network in Switzerland, they are made of lots of identical stations, or almost identical. There's no need to do anything, they just work. On the contrary, if you look into research automatic weather stations, these are stations that have been installed to answer a very specific scientific question. So if you look at these pictures here, you can notice that every station is different. It's a different setup for every station in terms of height of a station, kind of sensors, and also the surroundings. So the first challenge, as you have seen into these pictures, has to do about diversity. It's diversity in terms of measured parameters, sampling rates, in terms of sources of data. The data may be coming from database, web service, files. If this is coming from files, it's diversity in terms of data formats. I've seen all kinds of variants of CSV files, can be also binary files like top 2 or 3. And you might also have changes into the station setup at any time during the station lifetime, and any number of changes, impacting all of the above. If I look, for example, at the Davos Stilberg station, it's a research automatic weather station that got installed in 1975 and has been running since then. It has seen lots of changes in terms of types and number of sensors. It has seen also different sampling rates. It has been fully rebuilt several times. And I guess that nobody really looked so much into the old data. This is, for example, a file, real file from this session from 1976. I've just truncated the number of fields because it was way too many just to show on the screen. Actually, here into this station, we have sensors from multiple stations within this one file. We have also changes in the number of sensors within the same one file. So obviously the headers are not going to match the new content of a file. And sometimes also the sensors have been swapped over time. If we now fast forward to year 2000, and this is this new file here, we still have multiple stations sending the data into the same file, but now we have a station index or station number. At least it's a little bit easier to group. But again, we still have lots of fields, but you can see the number of fields is totally different between these two files, although this is for the same station. The ultimate goal that we have is actually, we want to start with research automatic weather stations data and make it fair. And it needs to be easy, otherwise it's not going to be done. So somehow we need some kind of magic happening here in between to make it happen. First requirement that we have has to do about standardization of the data. We need to handle all the different input formats and deliver everything into the same output format, with the same parameter naming and with the same metadata standard. So we can reuse the data, not knowing exactly where it's coming from. It's going to be transparent for you. The second requirement, this is reproducibility. We want to document all processing steps so that we can reproduce the processing at any point in time. We cannot have any manual editing of the data, otherwise we cannot reproduce anymore. And we'll decide to generate on the fly the data. And it needs to work for any period of a station's lifetime. If I now jump forward onto our new system from the point of view of the user experience, you can go onto our web service homepage. You will come to this page here. You just log in with your ORCID ID. The page is changing now because you logged in. Here you select Guest Job Submission here, and you come to this form where you can just upload your data. Here I've put a CSV file. You set a start date, end date, and you click on Launch Job. And here it is. You've got a netcdf file back, standardized. If you look into this file, you can see here the naming scheme. This is a netcdf CF naming for the parameters. You also have some metadata here, including SCDD search metadata. So now you're thinking, this is really the magic we're looking for. Of course, in magic, there's always a trick. Here, the trick is that I deceive you with this upload here, because behind actually there's another file that is injected here. So into this process, you have one file that is put here, and this is a configuration file that is per station, that describes all the processing that happens to the data from the station for the whole life of the station. This configuration file is going to be handled by our MeteoIO, Meteorological Data Preprocessing Library. This is something we started in late 2008. It has been in operational use for avalanche warning applications, and this is open source. If you look into MeteoIO, the principle of operation, you have a fixed list of processing steps. For example, in the reading of the data, we'll choose from many input formats with a system of plugin how to read your data. Then you can choose editing or filters or corrections to apply to your data. You have many to choose from. And then you can choose the output format in order to write the data, again through a system of plugin. And nothing is hard-coded. Everything is coming from the configuration file. We don't decide for you how your processing should be done, but you describe everything into this configuration file. And the goal is that this configuration file should be understandable by a human in several decades from now. So even if the software is not around, people could reproduce the processing that you have done. Now I want to show you a real-life example as such configuration file. As you can notice, this is in the INI format. It is structured as sections, like you see here, a section. Then, for example, here we define what is a file reading, so what is a plugin, and where to find the data. Here we provide basic geographic metadata, so time zone, coordinates, name, and so forth. Here we define how to read and understand the file structure, so column delimiters, how to parse the date and time, and so forth. Here we list the files that are going to contribute data to this dataset. Then we have another step where we apply some filters onto the data, like here this is for an unventilated temperature correction based on the UVAL paper. And finally, in the output section here, we define the output format, so netcdf. And we also define additional metadata that is going to be added into the data. So obviously writing the INI file is really key to the system, it's central to the system. So we provide extensive online documentation, but somehow I know you're not going to read the documentation, so we also provide a graphical user interface that is dynamically generated to always match the latest status of the software. In the documentation, you'll very often find direct links to the relevant part into the documentation. You could use also MeteoIO to do your data QA or QC. We have currently 41 filters you can choose from. You can stack as many as these filters as you want per parameter. And you have, of course, for every filter some extensive documentation. Like here you can see for an infinite impulse response filter. If you enable the data QA option and request some data, it will generate some logs. If you see into these logs, if you look into it, you see here at which step some events were generated, like here it was on the filtering. You see here the station ID, the parameter name, and the filter that triggered some events. And here you see the time step where something happened. If you just aggregate all of these logs, you can build this kind of table, for example, where you can see here for this station, there have been lots of events on every sensor. So most probably there's something like a data logger that is failing. On the other hand, if you look at this station, it's only one sensor that generated lots of events. So it might be that the sensor is failing, and you can go and look into it. So now, if instead of being only guest on the system, as we have seen as guest user, you can also be data owner. In this case, your data sets are going to be permanently on the system, as you can see here. And this means that you will have your INI files as well as your data connected to it. You will be able to automate the processes by submitting your data or pushing your data with SFTP, and also defining cron jobs to define how often you want to rerun the processing. Anonymous users will be able to see your public data sets, and they can get your data, your latest up-to-date data, as well as request data on demand by providing the start and end date as they wish. So it might be time to rethink the way we work with the data from these research automatic weather stations. The current way, as I described right now, is you have your automatic weather station providing data somewhere. You put a data lake just to be very generic. Then you have some very complicated scripts processing this data. And at the very end, we just send the data to MeteoIO to be standardized, and we have our data set. But instead, we could try to get MeteoIO much earlier into the process. We still have an automatic weather station pushing the data somewhere on a data lake, but then MeteoIO takes over the data from there and publishes the data. As you can see, the workflow is much simpler. What we are currently working on is being able from MeteoIO to access data, to pull the data from shared drives, from Amazon, S3, or Nextcloud, for example. If you have this kind of setup, you can benefit from notifications from the data QA. So you get notified when too many events have been generated for a specific sensor, and you can react. You can go back into your data and check what happened and react in a much more timely fashion. You can also enable near real-time data delivery for operational users, but also do what I would call a progressive data refining, where you keep on improving your ini file, adding more filters, fine-tuning and so on to have the best possible data quality. And at some point, you're going to be happy with the data that you have. You request the data over the period of interest, and this is the snapshot that you publish as a research dataset. So now we can look at the impact of this new workflow in real life. In real life, actually, we have very little time to care for automatic weather station data and research. We're busy with so many other things, with proposals and papers and so forth. So this is often neglected. And to tell the truth, actually, even for myself, if I have to choose between sitting in my office and doing data standardization, or working on a paper on some interesting research project, or even enjoying free time for myself, I'm not going to do data standardization. It's not my focus. If we look into the new workflow, what I get first, I'm empowered as data owner. I get control over my data. I can follow what happens without having to constantly go back to check into my data. It makes the whole data production much more robust because it's automated, because I can always improve the quality by putting new filters and so forth. So it's more robust and it increases the data quality. All of this is very important for me. I can really benefit from this. It makes my life easier. And on top of this, as a side effect, my data is going to be standardized and fair. And it comes basically for free to me. If you want to learn more about what I've presented, we have a GMD MeteoIO paper that presents how MeteoIO works, what is the principle. We have one paper about Initial, this dynamically generated graphical user interface. And we have one paper where we present an earlier version of the system as it was developed for the WMO's Global Cross Year Watch. Thank you for watching.